Hello everyone, today let's take a look at QP169, pretty simple geometric or negative binomial question where we basically just have the squirrel who's checking these trees in a park one by one looking for hidden acorns. Each tree independently has a hidden acorn with probability P. In part A, it's asking us what is the probability that the first tree with an acorn is the fifth tree the squirrel checks. And again, we know independently the probability of an acorn being within a given tree is going to be equal to P. So we have Bernoulli trials here, right? The probability of not getting an acorn in a given tree the squirrel checks is going to be 1 minus P necessarily, right? So if we want the first tree with an acorn to be the fifth tree the squirrel checks, that's going to mean the first 4 trees are not going to have an acorn and then the fifth one will, right? So what's the probability of that? Well, it's the probability that our first 4 trees do not get an acorn with probability 1 minus P. So 1 minus P to the power of 4 because they're independent events. And then after the first 4 non-acorns, we want an acorn on the 5th tree. So we multiply this right here by P again because they're all independent. So that's the answer for part A. Pretty simple. Part B should also be pretty simple. It's asking us what is the probability that the first tree with an acorn is found only after the first 3 trees were checked. So again, this is pretty simple. It's basically just asking us what is the probability that the first 3 trees were checked does not have an acorn, right? That's going to happen with probability 1 minus P for each of them. They're all independent, so 1 minus P to the power of 3. So A and B are very simple. Part C and part D are a little bit more interesting. Let's do part C first. So here we want to find the probability that the 4th tree with an acorn is the 12th tree the squirrel checks. So if this is tree number 12 over here, the 12th tree that the squirrel checks, we need to find an acorn under this tree. That's going to happen independently with probability P. So we know we need to find an acorn in the 12th tree that we check, but we want it to be the 4th acorn that we find, right? So that means that in our first 11 trees, we're going to need to have exactly 3 acorns found among those 11 trees, which means we have to have 8 trees without acorns. So just to write it out, for our first 11 trees, we need exactly 3 of them to have acorns and 8 of them to have non-acorns. The probability of this right here occurring, remember we're dealing with independent, basically Bernoullis, right? And we're trying to count the number of successes. What do we use for that? It's the binomial distribution, just like we talked about in QP85. So for the binomial here, we have 11 trees. We need to choose 3 of them to have acorns. They have an acorn with probability P, so we need to raise that to the 3rd power, indicating 3 successes, right? And then that means we have 1 minus P are 8 different failures like so. So this is the probability that we have exactly 3 acorns among the first 11 trees, and then we need to multiply that by the probability that we get an acorn in our 12th tree, and that will be the probability that the 4th tree with an acorn is the 12th tree the squirrel checks, right? So now we just need to multiply this right here by P. When we do that, that's just going to increase this power right here by 1. So this right here will be our final answer for part C. Okay, so that one was pretty simple as well. That's a negative binomial right there. The first 2 were geometric. And now part D, another negative binomial. We just need to find the probability that the 4th tree with an acorn is found strictly after the 12th tree. So if I have my 12 trees like this, I don't know how they're such bad trees. I forgot how to draw a tree apparently. But in order for the 4th acorn to come strictly after the 12th tree, so anywhere from the 13th tree all the way up to the infinitieth tree, I'm basically going to have at most 3 acorns to be found among the first 12. But that probability right there is just going to be binomial, right? It's going to be the sum of a bunch of binomials, right? The probability that we have 0 acorns found among the first 12 plus the probability that we have 1 acorn found among the first 12 plus the probability that we have 2 or 3, right? Probability that we have 0 trees, first of all, that have an acorn among the first 12, well, that's just going to be 1 minus P, the probability that each individual tree doesn't have an acorn raised to the power of 12, again, because they're all independent. Now the probability that exactly 1 acorn found among the first 12 is going to be 12 choose 1, right? The number of ways that we can choose which tree will have the acorn that we want to find, right? And then times P, and then we have basically 1 minus P to the power of 11 for our 11 trees that we don't find an acorn in and our 1 tree that we do find an acorn in. Now again, the probability that we find 2 acorns is again going to be binomial. We're going to choose which 2 trees out of the 12 we're going to have acorns in, raise P to the power of 2 for the 2 trees that we do find the acorn in, and we raise 1 minus P to the power of, now in this case it will be 10, right, for the 10 trees that we do not want to find an acorn in. And then finally, the probability that we find exactly 3 acorns among the first trees, well, they're going to be 12 choose 3, right? We have 12 trees, we're choosing 3 of them to have acorns, raise P to the power of 3, and 1 minus P to the power of 9 now, right? And then the final answer to this question will just be when we sum all 4 of these different terms up, we can write it more simply in summation notation, right? I have my sum going from, let's say, k equals 0 all the way up to 3. I'm going to have 12, and I'm going to be choosing k, right? And then I'm going to have p, raise that to the power of k, and then I'm going to raise my 1 minus p to the power of 12 minus k, right? So this is just the sum of a bunch of binomials, and then this right here will be our final answer. So again, that's just the probability that the 4th acorns come strictly after the 12th tree, which is what we were asked in part D. So that concludes every single part for this question, right? This was B right here. So just a simple geometric and negative binomial question.